I want to find the hydroxide ion concentration and pH of a 0.33 molar methylamine solution. When I think of methylamine, solubility doesn't really play a part to me, right? I don't know that as a soluble salt or as anything of that nature. So I need to figure out what is the reaction for that. So the reaction is CH3NH2. And if it's a solution, we know that means that it's in water. So I've got my water. Oh, now, hey, this looks really familiar, right? I'm going to have to add a proton to one and take a proton away from the other. So we know that to get a hydroxide, we are going to have to take an H plus away from the water term. And over here, I'm going to have to add an H. So this is now going to be CH3NH3 plus the OH minus. Okay, well, I've got a reaction. You know where this is leading. We're going to have to use Rice. So I need to look at initial concentrations. So the only initial concentration I was given was for the methylamine solution. So this is going to be 0.33. This is a liquid. We don't care. We had 0 and we had 0. So what is the change? Well, on the left, remember this is minus x. On the right, we have plus x and plus x. So then we need to find equilibrium. So we're going to add straight down. So I've got 0.33 minus x and x and x. So what do you have to do next? Well, the methylamine, since we made OH, we know this is a base. So I have a Kb. To find the Kb value, make sure you check your textbook. It is 4.4 times 10 to the minus 4th. That's going to equal the product, so x times x, which is x squared, over the reactant, and I'm going to hope that we can go ahead and approximate because life would be much easier. So if I do that, I'm going to cross multiply, take the square root, and I get 1.204986 times 10 to the minus 3rd molar. Now, is it okay that I made that approximation? So remember, how do you do that? Well, you're going to take that number, and I'm going to divide by what? That's right, I'm going to divide by the initial concentration. So I'm going to divide by 0.33, and then I'm going to multiply by 100, and I get 3.7, which is less than 5%, so this was okay. So I have found, there's my concentration. It doesn't have the right number of significant figures, but we can fix that, right? So how do we fix that? Well, I need how many? I just need 2. So this would just be 1.2 times 10 to the minus 3rd molar. But now I've got to find a pH. Well, I can find the POH, right, because I have the hydroxide concentration. So I can do the POH equals negative log of the hydroxide ion concentration. And when I take the negative log of this number right here, remember, use the one that isn't rounded. We want 2 decimal places, so I get 2.29. But I want pH, so pH is 14 minus 2.92. So that means my pH is going to be 11.08. So really this kind of squiggly one here, that's the answer with the right number of significant figures, and then here's our pH.